Thank you for joining us today for optimizing real-time playout in the cloud with coralPlay and Zixi. My name is John Weskitz, and I run the partnership and marketing groups at the company. Today, I'm joined by Natram Dionarain, Senior Sales Engineer for Partnerships, as well as coralPlay's CEO, Peter Hajitofi, Director of Video Technology, Gavin Smith, and Chief Software Architect, Peter DiPaolo. Today's agenda will be to give a brief overview of Zixi, get an introduction to coralPlay TV and their products, how Zixi has been integrated into coralPlay with a live demonstration, and then we will take questions at the end. So please put them into the Q&A tab that you can see. And we will answer as many as we can. If we aren't able to get to your questions, we do have your name and email address with the question, so we will give you a personalized response if we're unable to answer them live. So to start with, why is this partnership important? With this integrated offering, our joint customers are able to seamlessly shift towards software-based infrastructure while maintaining all the functionality and reliability of traditional hardware-based playout solutions. coralPlay Playout software offers automation control and a video pipeline, delivering video and audio in a variety of output formats with the ability to apply graphics and subtitling. And you are able to leverage reliable signal distribution with Zixi to AWS or Zixi Receivers in the cloud with ultra low latency, error-free live content delivery over IP with up to 45% packet loss recovery. So who is Zixi? Let's quickly give an introduction to that. Our software-defined video platform, the SDVP, is used by broadcasters and content creators to source, manage, and distribute live and live linear channels. Those are our two primary use cases, over any IP network, using any protocol, on-prem, or with any cloud provider using any edge device. We therefore have the largest ecosystem for live video in the world, with over 100,000 global instances in over 100 countries, coming up on 1,000 brand name customers all over the world, and over 250 technology partners enabling unmatched global connectivity anywhere to anywhere. So what are the components of the SDVP? There are 4 pieces. The first is the base Zixi protocol and other transport protocols that define performance, define what the quality of service is going to be, and how the viewers are going to experience it. High quality video means more viewers, simply put. Platform interoperability means not having to mandate the time and effort of a new SDK development. And then once all of the endpoints are connected, signal path continuity. The second piece is the video solution stack coming from 13 years of innovation that allows for any configuration, complex deployments across any IP infrastructure, complex live transcoding and video editing, the management of metadata for ad insertion and closed captioning, and very importantly, being able to achieve and prove service level agreements. Next is the Zixi-enabled network of hundreds of thousands of worldwide endpoints, hundreds of integrated devices, software platforms like coralPlay, and service providers that have standardized on Zixi. This community allows for extreme use of connectivity, speed of deployment, which can now be measured in minutes rather than historical times of weeks or much longer, and the ability to start small and extend operations and services as necessary with agile infrastructure and adaptive incremental architecture. And the last piece is Zen Master, a unique control plane across all of these connected devices, networks, and environments that operators and engineers can access from anywhere in the world, enabling virtual operations, which is even more important in a pandemic, along with delivering deep audio and video analytics and the ability to manage it all at maximum scale. So how does the SDVP enable these 4 components? To start with, Zixi has the best protocol in the industry, utilizing advanced techniques such as dynamic forward error correction and ARQ that result in bandwidth efficiencies to 40%, sub-second worldwide transport latencies, and stream bit rates to 5 gigabits per second. However, we also realize that there are other protocols being used for a variety of reasons. So we also support 16 additional protocols, including the standards-based RISC, RTMP, HLS, NDI for live production, and very importantly, the ability to switch these protocols using the SDVP. Zixi's patent-pending hitless failover is an extension and improvement of SMPTE 2022-7 with an industry-leading packet sequence alignment algorithm. This algorithm works much like a DNA sequence alignment, reconstructing the original sequence of IP packets that best recreates the original stream fragments and allows for up to 8 nines reliability depending on engineering architecture. We support multiple codecs, adding more and more all the time, and the mantra that you'll keep hearing from us: any IP network, any protocol, and any cloud. Live quality transcoding is very difficult, but we do it at the highest quality, which improves customer adoption, satisfaction, and retention. Zixi also supports other features and functionality broadcasters require, such as recording, time-shifted delivery, auto-slating, and network transport and content quality analytics. So not only can you understand what is happening in your Zixi deployment, but also how it impacts your business. Zixi has spent a lot of time and effort developing relationships with coralPlay and other 250 technology partners who have integrated the SDVP into their devices, software platforms, and standardized on Zixi for their service offerings for extensive worldwide interoperability. Overseeing all of these components is Zixi Zen Master, which allows for the rapid provisioning, deployment, orchestration, and monitoring of the end-to-end deployment at scale. It allows management of the third parties of the Zixi-enabled network through their own user interfaces, giving simplicity across complex multi-party supply chains. And the level of data available and centrally visible is unmatched from anything else that you'll find in the broadcast industry. Zen Master provides alerting, history, automation of repetitive events, scheduling, detailed reporting, and very importantly, root cause analysis of exactly when and where an error occurred in the deployment. So for example, you can tell if a packet was lost, did it hit an iframe and affect programming, or did it hit a SCSI marker and affect an ad? And then you're able to report that impact to the entire team and management. This is a quick representative subset of our worldwide customer deployments, some of the biggest names in the industry. And here are a few of the partners in the Zixi ecosystem, everything in the end-to-end broadcast workflow, from integrations in cameras, encoders, decoders, IRDs, QA platforms, forensic watermarking software, editing tools, and playout systems like coralPlay. So with that introduction to Zixi, I will turn it over to Peter Hajitofi for an introduction to coralPlay and coralPlay. Peter?
Thank you, John. Hi, everybody. First, I just want to just give you some background about on coralPlay. So coralPlay is a fairly new company. It's coming up to 5 years old now. It was formed in May 2016. We're a British company, headquartered in Leeds, which is in West Yorkshire in the north of England. We're privately owned with no external investment, and we are growing organically. And what we've been doing, we've been developing cloud native solutions using cloud native technologies to take advantage of the elasticity and the redundancy that's offered in the cloud. However, our products can also be hosted on premises if that's what our customers want to do instead. Our products are for Playout and a certain amount of media management. And finally, just to say that we are a technology provider. We don't provide a service per se, but we provide the software so that so that our customers can run their channels. Next slide, please. So this diagram here is it shows our software stack. So at the bottom of the diagram is the hosting. And what we're showing here is that we can host our software either on bare metal servers, so it will run on standard off-the-shelf hardware such as Dell, HP, or Supermicro. It can run on virtual machines under VMware or KVM, or it can run in public clouds such as AWS, Microsoft Azure, and Google Cloud. And the software's been designed using microservices. So instead of one big monolithic application, we have instead smaller services. All the software is containerized using Docker and deployed and orchestrated using Kubernetes. And this has a number of advantages. For example, upgrades are simpler and less risky. So rather than having to upgrade one large monolithic application, we're able to replace only the services that are affected by any changes. And these upgrades can be done on a live system. Secondly, the orchestration is able to monitor the health of each service and is able to restart any failed components automatically. And in addition, if there's a failed host, using the Elastic services, it's possible for Kubernetes to spin up replacement hosts. So above the orchestration layer is our monitoring layer, and this is where we use industry standard open source tools. We use Prometheus to gather data about the health of the system, and we use other tools such as Grafana to process the data and to provide useful dashboards and statistics to help monitor the system. And above the login and statistics layer are our applications. The main application is coralPlay, which is a Playout product, and it's supported by two other products, coralMAM and coralFlow. coralMAM, as the name suggests, is a media asset management product. It stores metadata. It provides the ability to search and find media. We create thumbnails. It provides other tools as well. And there's a workflow engine called coralFlow, and that performs a lot of non-real-time tasks, such as content discovery, media transfers, schedule uploads, and After Effects pre-rendering, and so on. And above the applications is our API, which provides for monitoring and control of the system. The API is fully featured. It's used by our own web client for control, but it's also available to third parties. And finally, for security, we use standard tools. We use Keycloak, OAuth 2, and OpenID Connect. So next slide, please. Just a little bit more about coralPlay. coralPlay can scale. It's been designed to scale. It can scale up to hundreds of channels. It's operated entirely via a web browser, and we use Google Chrome. It's got extensive user access right control. We've recently added multi-tenant feature to support a number of different clients all on the same system at the same time. And with the user access rights, the various parts of the system can be separated. There's numerous redundancy options, and it's very easy to deploy new channels for short-term events, and they can be decommissioned just as easily after use to save costs. Next slide, please. So this diagram here is showing the demo configuration. It's actually running in AWS, and And I'll just try and explain this. At the center are the core workers, and it's the core workers that run the schedules. They manage the login, they manage the monitoring. And on the right hand side are the pipelines, and it's the pipelines that do all the video audio processing. So what happens is that the pipelines pull data from the core. They pull the sort of the playlist and the rundown of the events that need to be played. And in software, they manage that playout, playing out each event, overlaying graphics if necessary, subtitling, SDVP triggering, and all that's needed. And in this configuration, where we've got Zixi receiver and Zixi feeder integrated, and we are taking an input from Zixi Broadcaster as a live input, and we're outputting the outputs to Zixi Broadcaster. And for this demo, we're using the output of channel 1. We're looping that back in to be an input to the other 2 channels. So channels 2 and 3 have live sources. So all the media is stored in an S3 media bucket, and the media is pulled ahead of time onto the pipeline hosts. And we're using RDS for the database. We're using the EKS service cluster for Kubernetes. We're using the Elastic Load Balancer for connecting to the system securely. We're also using a jump box for maintenance of the system and isolating the VPC from the outside world. So next slide, please. So a little bit more about what goes on in our pipeline. So this is just an example of what a video pipeline could be internally. So it provides playout in SD, HD, and 4K. It supports a number of different codecs, including H.264, H.265, HEVC, MPEG-2, XDCAM, DV variants, and AVC intra. It supports PCM, AAC, MP2, and AC3 audio codecs, wrappers at MOV and MXF, and the player is universal. So instead of having to pre-transcode, we can play out mixed formats on the same timeline. And the input and output can be NDI if hosting on the ground, or in the cloud, it can be MPEG-2 or H.264 transport streams. And on board, we have the integration with Zixi, graphics, there's subtitling, there's switching, there's keying, there's loudness control, and automatic up-down conversion. Next slide, please. So at this point, I think I'm going to hand over to Gavin, who's going to explain in a bit more detail the Zixi integration.
Hi, thank you. Yes. So there's a lot in the slides, so I'm going to try and unpack it. So the video pipeline's transport stream output uses the feeder SDK to connect to a Zixi broadcaster or a Zixi receiver. And it can effectively, what it does is it pushes the content. Now on the pipeline's input, we use the Zixi client SDK to pull the content from a Zixi broadcaster or feeder. Onto the second point, the Zixi ecosystem is mature, as John has demonstrated, and there are many customers which already make use of Zixi solutions. So coralPlay can simply slide into an existing deployment. On to the third point, we're going to break that down a bit because we really need to unpack this. In our tests and our customers' experience, network resilience and reliability is an issue within these cloud networks. And we have observed that while it is possible to transmit UDP data across the network, there are some issues that quickly become obvious. And it's important to set the context of these deployments. In a cloud environment, networks are software defined and resources are shared, for example, shared hosts, shared network, et cetera, et cetera. So it's not possible to guarantee a quality of service. Of course, all this is exacerbated by the fact that UDP by its nature is unreliable. So what problems do we see? You're probably asking yourself. So we have noticed that one of the following patterns occurs during our testing. The first common scenario is network packets are lost regularly for brief periods, say every 30 seconds, and the loss will span a few milliseconds. The second common scenario is that network packets will be delivered reliably for a few hours, but then there will be some significant loss for a more extended period of time. I should add that your mileage will probably vary in your tests. For example, the reliability may be a function of the stream bit rates or even differ from cloud provider to cloud provider. When using Zixi solutions, we've been able to devote more time to our software rather than troubleshoot packet loss. The next point is in respect to receiving transport streams. And there are a few points to consider. Firstly, we want to minimize connections directly to the video pipeline. Connections to the pipeline could be used as an attack vector. Secondly, the elasticity, we have already touched on this, of the cloud means that our pipelines could get deployed or redeployed onto any available instance. This results in a change in host name and or IP address. To handle these problems, what the pipeline does is it initiates a pull connection using the power of Zixi and connects from the pipeline and pulls the stream from a Zixi broadcaster or feeder. Now, this will work regardless if the pipeline is redeployed to a different instance, so no reconfiguration is required. And just a final point, the feedback that is provided by Zixi in the integration is simply fantastic. Now, I'm not talking merely logging, because the SDVP publishes numerical metrics, which we publish up as Grafana stats. If the network is really struggling, it's possible to get good visibility both historically and in real time. And my colleague Rob will be able to demonstrate these Grafana stats during his live demonstration. So those are just some of the benefits we have appreciated. And I'd like to hand over to my colleague Rob for a demonstration.
Okay, thank you, Gavin. Okay, let me share my screen. So thank you everyone for coming. My name's Rob DiPaolo. I'm the Chief Software Architect at CoralPlay. So what I'm going to do today is show you a live demo of our system running in AWS, as Peter described. So what we've got here is our client is a web browser. We only have a web browser, so all of our interfaces into the system are via the web. So this system is running in AWS, so I can log in now, and here we have our sort of initial dashboard when you come into the system. So this gives access to the different areas of the system. We have Playout, we have MAM, we have some sort of engineering UIs and the configuration. And then on the right-hand side here, we also have some links to some of the external tools that we've integrated, which I'll show you a little bit of later. So what I'll do first is I'll come into the configuration quickly and just show you just sort of how that slide that Pete showed you maps to what we have configured here. So if I come to the channel configuration, we can see here that we have 3 sort of main channels configured. So these channels are effectively like the schedules, like the linear playout schedules. So we can configure these, we can create sort of hundreds of these as required. And we can configure these in different frame rates within the same system. So we can run PAL and NTSC within the same system. And we can also sort of configure time offsets as well for the different channels. So we actually schedule everything internally in UTC. And then we just change the presentation time in the user interface and also for the as run logs. That way we're not susceptible to kind of clock changes affecting Playout. It can all be done just in the user interface. So what I have is 3 main channels and then a couple of prep channels. So the prep channels are just channels that don't have pipelines attached to them. And you know, for these channels, there's various configuration, which I won't go into in detail for this demo. And then, so in order to sort of play out a schedule for a channel, what we have is the concept of these video pipelines. So what these pipelines are effectively they're a full like rendering pipeline, which are configured using YAML templates. So if I have a look at one of the ones I have configured here, what we wanted to do when we designed the video pipelines was to kind of model it on the old SDI way of doing things, where you have different components like an AV input, for example, a video player, graphics players, compositors, etc. And then make it so you can just plug those components together in whatever order you need them to build your kind of video rendering pipeline. So in this particular case here, we have an AV input which is configured to pull from a Zixi source. I'll show you that in a moment. And then we have a SCSI input processor. We've also got a primary video processor. We've got some scalers, and in our compositor we've got various graphics layers, including an HTML renderer. And then we can then send that on the output through some various audio conformers, and then we can configure output. So in this case, on the outputs, we've got a low-res HLS output that we're just using for monitoring, and also we have a transport stream output. But we can configure these in sort of any way. So we have another one configured here, which we're also using, which is slightly more complex. It doesn't have an input, but it has a sort of primary and background video and a DVE, for example, which then goes into the compositor as different layers. So and these are sort of YAML templates, so we can easily sort of download these and sort of use them across different systems, and we can just really configure these in any way required for our customers in order to produce the sort of the video outputs that they want. And then when it comes to actually deploying these pipelines, once they're deployed in the templates, we can set any kind of number of variables. So in this case, we've got sort of where we're sending it to. We've got some variables for the Zixi input that we're pulling it from, and the Zixi stream names, for example. And we actually deploy these within Kubernetes as a pod within Kubernetes. We have quite a tight integration into Kubernetes, where we as these are created, we actually create all of the services required within Kubernetes and deploy them and monitor the status. So if I then come back to the home screen here, before I go and show you the playout section, I'll just quickly show you the MAM side of it as well. So what we've done with the MAM, if I start with the locations here, is we've effectively started off just building a MAM system required for playout, so that you can do everything you need for playout without having to purchase an external MAM system. So in this particular system, we have all of our content on this S3 location here. This UI is just monitoring those locations and showing you sort of space, free space and remaining. It's quite useful just to show you what's currently there. So all of our content on the nearline storage is in the is in S3, and then we have some pipeline caches. These are just pipeline cache, local caches on the pipeline hosts, where we cache content to for playout. We do actually have the ability to play directly from S3 as well, rather than actually caching it, which has some pros and cons. But in this particular demo, we are caching the content to local storage, and we manage these caches using an intelligent sort of cache management system, so we can only cache the next n hours or certain amounts of content. And then here we can also see all the content that is within the system. So we can import content using workflows, and we can generate metadata and things like thumbnails. For example, here we've got on this bird clip, we've generated a few different thumbnails, so we can do things like first frame and last frame, as well as just a short way in. We have you can see all the kind of basic metadata, so we can do all the usual things of of adding titles, tags, and this is all editable within this UI. And also, we pull back, other kind of metadata and information about video codecs, etc. And in here you can see sort of where everything is, and there are kind of you can delete, do manual transfers, etc. And we treat all assets as equal. So video, graphics. We should have some subtitles in here somewhere, yeah. Subtitles and even things like channel schedules, we also treat them as assets. So we can actually import schedules into the system ahead of time, and we can manage them in the same way that we manage assets. So we can make sure they're available and move them wherever they're required. This is all searchable as well via these search bars that we have in a lot of these UIs. So you can search for specific asset types, and various other information. And this allows you to save searches and has search history, so you can sort of see previously what you've looked up. And we're constantly improving our MAM as time goes on and adding more and more features to it in order to meet the needs of our customers. And finally, we do have support for things like markups, which are like transmission segments. So you can like add your transmission segments in here, and we can import them from external systems as well. So if I now come back to the home screen, I'll show you the Playout section. So within the Playout section here, the main view, we can see a summary of all of the channels that we have within the system. So this is a live view showing current status of all the channels. So these prep ones sort of have no status, but the three main channels we have here, we can see this one's on air. You can see what assets currently playing, and we can see a live progress. I'll talk a little bit more about this contribution channel in a moment. And then we have this third channel, which has nothing running in it currently. And I'll quickly show you in a moment just how we can put some assets in there and get that channel working. This view, there are a couple of views. It's designed to make it easier for operators to manage lots of channels. So it's all kind of searchable. And it's got a kind of a filtered view where you can do a kind of monitor by exception by only showing errors. I can show you that, actually bring up some errors in a moment. If we then click on one of these views, we get a sort of a more detailed view here of what's actually happening in the channel. So at the top here, we can see some sort of basic stats. So, the current on-air event. This one would show the next error if there are any. This is showing the next queued event, time to next queued, and this is just a kind of breakdown of all the different event states within the list. And this is all configurable. You can change all various settings of the statistics there, and we will add more of these as time goes on. A lot of the components of the UI, can all be collapsed and customized as required. The main view here is showing the individual events within the playlist, and this is actually a tree view, so you can expand out and see the secondary events on the primaries, and you can scroll around and see what's coming up. And then down the bottom here, we have a timeline view of what's in the list there, and this is all sort of scalable, and you can sort of all move around in it. It's all kind of interactive. And then finally, on the right-hand side here, we have a low-res preview. So at the moment, this is just a low-res HLS output that's just showing what's being sent on the output of the channel. Now, this particular channel is being sent out to the Zixi broadcaster, and it's also sending SCTI markers. So there's some breaks in here. So we've got SCTI in and out blocks around the breaks. And then we have this second contribution channel here, which is just pulling that output from that channel as a live input. So this is a special type of channel that we use for like ad insertion, where it's just a pass-through channel that's waiting for the SCTI triggers, and then it will then play, a different advert break. For example, in this case, it will overlay videos when it gets the next trigger, for example. So this using Zixi makes this all very simple, because we can just go and pull the streams we need directly out of the broadcaster, and we don't need to worry too much about where anything's hosted, and we can be sure that we're going to get reliable inputs. And then, so finally now, if I come over to this channel here, so this channel is just an NTSC channel. I've got it running at a -5 offset just to show you the output there. But I thought it'd be nice to show you by just coming to the asset view here. So just dropping some assets in and just creating a very simple list. So as I said, this user interface, it's all completely editable. It's all drag and drop. So I can just come in here and drag some of these clips and drop them into the playlist here. So these now all come in as primary videos. Then I can, for example, do a search and find some graphics. So if I drop my Coral logo, so that's dropped that as a secondary, and I can expand that out now. And I could go, say, get this lower right clip as well and drop that on. So then I can add these onto different layers. So put that on layer 2. And then within the grid, there are various properties that you can edit, all the scheduling information, etc. But we also have that in the sidebar here. So what I can do, for example, is just set this to start, say 5 seconds in. So I can just set like parent start plus 5 seconds. And maybe I can end that sort of parent end minus 5 seconds. So that's going to just schedule that to start and end just slightly after and before the event. And I can do the same, say, with this lower right. Maybe I'll do that at, say, 10 seconds and minus 10 seconds. And also this one has some template fields in it. So there's we can do like dynamic text insertion. So for example, I'll just set that to something I've done before, and I can do a webinar demo for the subtext. So it's just got these 2 text fields, so I can apply that. And yeah, and then we can add I'm done. We can add other events. So we have like all sorts of other event types in here. So for example, we can do like simple comment events where we can just put sort of stuff for operators. So we can write sort of anything we want, which just show up as comment events in the list for the operators. And you can also just drag and drop these events in here, for example, and just manually create them. So for example, I can just do that and put something that doesn't exist in. So this, as I say, the UI is all editable. So to make it nice and easy for operators, we can also load in schedules. So if I click on here, we can load schedules from local files. So you can just drag and drop or browse, and we support all the usual formats, BFX. We've got our own JSON format. We can also import sort of Pebble Beach formats like Marina and Neptune sort of natively without having to do any conversions ahead of time. And as I mentioned earlier, we can also store schedules within the system. So rather than having to deal with files, we can just load schedules that are already stored. So for example, I've got this sales demo one, which I can just append on the end here. And that will append in the background. And then I'll have a slightly nicer list that I made earlier. Down the bottom here, and we can see here this has got some other things like event types, etc. in them. So now if I queue up this list, that will go ahead and validate all the content, and we can see that some of this content was missing, so it wasn't on the pipeline cache. So what this has done is then gone and initiated some transfers to go and get the content where it needs to be. So this all happens live using our workflow system, and is all managed by our sort of cache managers for the cache, and we can actually do multiple hops if we need to. We can see this clip here doesn't exist, as I was saying earlier, so now we can see we've got an arrow shown at the top here. I'll start with this playing as well. So we can see we've got an arrow shown at the top here, and that arrow makes it all the way up to this top level here. So now we can see very clearly that there's a problem in channel 3, and we can also filter for those kind of errors. And then if I just pop back into this channel and pop over to the preview, we can see now there's that that graphic that popped up, and the other one now pops out with the dynamic text in it, which you might not be able to see on the screen size. So that's just a simple example of showing how we can how dynamic the user interface is, so and how fully featured it is. We also, on the monitoring front, we have a sort of multi-channel timeline view where we can go and see what's happening across sort of multiple lists. And again, this is all interactive, and you can create kind of multiple tabs in here. So if you've got lots of lists, you can group them up into tab views for monitoring. And then on the monitoring side as well, we have sort of an asset usage view here, which we use sort of primarily to drive our automated processes, but this is also useful for operators because you can see sort of where all content, including things like the channel schedules and the graphics and secondaries, are being used across the whole system. So you can see your sort of usage counts and first and last usage times, etc., across all lists. And you can additionally generate sort of queries, for example, like show me everything that's missing. which can also then be exported as well into sort of Excel format, for example. And then on the opposite side of that, we have the as run information. So we can see across the system effectively everything that's happened across all the lists. So traditionally this would be written out to files, but we have this all via our API, and it's all searchable as usual. And actually we keep a complete kind of event lifecycle history for every event, so we can see everything from creation through to deletion and when all the state changes happened, and additionally with all the secondaries as well. So it's a fully featured as run, and that can all be exported into various formats as well. And for traffic integrations, the traffic systems can easily just access our UI directly as well. And then finally, I'll just show you quickly the workflow here. So we can see here all the workflows that have happened across the system, including ones that have failed. So what we term as a workflow is just anything that's sort of non-real time that's needed for supporting the playout. So we use these for all sorts of things. So for example, here you can see these fulfillment workflows have been created that sort of say this clip's required on this location, and then we've gone off and created as part of the workflow a transfer to transfer that across. But we also use them for like loading schedules, for importing assets, for doing asset deletions, and we can configure these you know, to do all sorts of you know, sort of things like on imports for media preparation, all that kind of stuff. And this view is just showing a kind of a status view of what's been happening across all the workflows. Yeah, so I think that's sort of a short overview of the playout side of things. Just quickly, I think it's worth showing you just a little bit on the user management side of things. So the system is multi-tenant, and we have access rights. And again, we configure these using YAML templates, so we can configure sort of different types of users, you know, operators, people with only view access, for example, and we can configure you know, various groups and add people into groups. And we can also in here, although I don't have any configured, configure API clients to give third parties access to the system, and we can you know, we can lock that down to just specific APIs or just, you know, specific areas depending on what those clients need. And you know, we can add users in here and and so on. What I won't show you here is that actually this is you can see here we're in a partition, so we can actually create multiple partitions within the system, which then means when you're logged in as a user within that partition, you only see your section. So it's like the multi-tenant thing. So in this system, we're only seeing what's in our own partition. Yeah, and then finally then I'll just quickly, because we're running short on time, just show you the stats. So as Pete mentioned, we've integrated a lot of third-party tools to help monitor the system, and we deploy those as part of our standard stack, and we've got them reasonably tightly integrated. So if I just click on stats here, this will take us to a link to Grafana, which is showing some of the stats that we're generating from Prometheus. So this simple dashboard here is just showing you know, all the host information, so the number of hosts in the system and all of their, you know, health, RAM, you know, free disk space, etc. And we can actually generate, and we do generate alerts off of some of this information. So if, you know, something's using too much CPU or RAM, or if a container gets restarted, we can generate alerts using the Prometheus tool, which can then be sent to, you know, Slack and emails and so forth. And also we can pull out, you know, see we've got a lot of dashboards in here. We can, you know, pull out stats from, you know, various things. So for example, this dashboard is just showing some of the stats that we're pulling out using the Zixi Receiver API. So we can like closely monitor the you know, the inputs, and we've got another one for the Zixi feeder one, so we can see for each of our pipelines, you know, how they're performing, how the network's performing, and lots of other things. We also have you know, sort of logging and some other bits which I won't show you for this demo. Okay, so I think that's a good place to leave this now. So I think I'll pass back now to John, who will finish up.
All right, thank you, Peter. Before we get into questions, and we do have a number of questions. I'm going to go over some key takeaways, but also note that I started a poll that will indicate how you would like to be followed up, if it's by one or the other Coral Bay or Zixi organizations, or possibly both. Let us know in the poll. So before we get to the questions, and we have quite a few, so thank you. If anybody else has any, please put them into the Q&A tab. What are the key takeaways? With this integrated offering, customers are easily able to deploy a software-based playout solution that is compatible with any existing or future Zixi infrastructure. Efficient resource allocation with coralPlay and Zixi optimizes cloud resources with an event-based design to reduce operating costs when running in the cloud. And coralPlay's integration with the Zixi SDVP improves reliability of signal distribution, providing ultra-low latency transport over any IP between the video pipeline and the cloud. So let's move into some questions. We'll first go to Natram from the Zixi team. What is the delay from a live Zixi input to an output on the other end?
Thanks, John. The Zixi protocol is capable of doing very low latencies, 20 to 30 milliseconds, and it's totally dependent on the network conditions. So we typically recommend customers to do 3 times the round trip time for the Zixi protocol.
Thank you, Natram.
Can I just add something to that, John?
Yep. Please.
Yeah, so if you're referring to a live input coming into the pipeline and then being passed through back onto the Zixi output. So at the moment, by default within the pipeline, we have a 10 frame sort of pre-roll or buffer, and that can be reduced or increased. And then there's also other delays, sort of like encoding, decoding delays that you'd need to consider as well. Yes, so I'll leave that at that.
Okay, and a follow-on question for the Coral Bay team. Can you control coralPlay software via API?
Yes, you can. We do have a comprehensive API, and all the functionality that you saw Rob demonstrate, that's all done by the API. So our own UI actually uses the API, and all that's available for third parties.
Next up, how many virtual resources are needed with GPU, CPU, and RAM per channel? Is there a difference in live and clip playback with graphic?
Yeah, that's it's a tough one to answer because I guess it depends on quite a few different scenarios. But as a kind of a general rule, what we would say is for an HD channel, that's doing some sort of basic graphics and output, we would generally say you'd need about 4 cores of dedicated CPU and about sort of 4 to 8 gigs of RAM. We do everything using CPU encoding. We don't require GPU at all. But obviously it depends a little bit, because if you make much more complicated pipelines, then they might need more. And if you use less, then they need less. And then our control layer is very optimized. We can run quite a few channels on just a couple of sort of 4-core, 16 gigs of RAM hosts.
Another detailed question: what do you use to manage your on-prem deployments of your microservices in Kubernetes?
Yeah, so we use Kubernetes on-prem. So we install Kubernetes using kubadmin, and then we manage it all using the Kubernetes dashboard and command line.
Do you have any traffic system interfaces?
Yes, yeah. So we can read playlists in various formats, and we can generate as-run information in various formats. We are open to doing, for projects, if we needed to do a specific integration to a specific traffic system. And we also allow, our APIs are all available if traffic systems want to integrate directly with us as well.
Yeah, can I just add, we do support BXF, and
Yeah.
we have interface to MSA Focus, Pro Consultant Louise, and some custom traffic systems.
Brilliant. Next up for the Coral Bay team, does the Playout effects include a picture-in-picture squeeze?
Yes, it does. Yeah, we have a DV that we can use to squeeze. We can have multiple DVs within the same pipeline as well, so we can squeeze multiple layers of video, and we can squeeze live as well as pre-recorded content.
Can you include data-driven dynamic graphics in the channel template?
Data-driven. So we, at the moment, the data needs to come via the playlist, but that is something that we are working on for some of our customers, which is, to be able to pull data from external sources.
Have you integrated with any scheduling products? And if so, are there any preferred?
Do you want to take that, Pete?
Yeah, we have interfaced to some. We've interfaced to MSA Focus and Pro Consultant Louise. We don't really have a preference. We're open to interfacing to whatever the customer chooses.
Okay. How is coralPlay sold? What is the business model? How are costs calculated?
Okay, so we can offer coralPlay on either a perpetual licensing model or a pay-as-you-go model, and that's really down to customer choice. And we're open to discussing what's best for the customer.
And is there a total cost of ownership per channel or month? Is that dependent on the customer's deployment?
Yeah, again, if the customer opts for pay-as-you-go, then there'll be a monthly fee. If they opt for perpetual licensing, then depending on where it's hosted, there may be some costs associated with the platform. If it's hosted in a cloud platform, for example, which would be monthly generally.
Is there a maximum uptime defined for a pipeline?
It's asking why. So the reason behind that is that, especially in large organizations, you may have customers who will try and tweak, for example, pipeline settings and redeploy them. And so it's just good for historical reasons, just to be able to see when the pipeline was last restarted. And, we live in the real world. There are things like software crashes, so pipelines may crash, and just seeing when that last happened.
Is it possible to record local playlists that are on air?
Not currently. I can answer that. Not currently. We are planning to add record features onto the products, but at this point in time, there is no facility to do that.
Okay. Let's not let the Coral Bay guys answer all the questions. Natrum, how can this solution help with remote production?
That's a good one. Recently, Zixi launched support for NDI. So with like NDI and remote cameras, we can take that NDI and then send it into the cloud, and it becomes NDI when we egress it again.
Brilliant. Back to the coralPlay team. What about security in the cloud? How do you make sure a customer's content and playlists are protected?
Okay, that's a good question. Yeah, so our user interface and APIs are all secured using kind of standard sort of web protocols, OAuth to OpenID Connect, which is all the stuff used by Google and Facebook, etc., and all using all encrypted over HTTPS. And then when content's uploaded to the cloud, usually that will be uploaded to S3 or Azure Blob, etc. So we can use encrypted storage. So the your content will be encrypted even within those locations. And the same when we transfer stuff around, we use encrypted volumes, and we use HTTPS traffic, etc. So everything is secured. And then the cloud platforms themselves obviously invest a huge amount of resources into making sure their platforms are hardened. So we benefit from all of that as well.
All right, thank you for that. We've got time for one or two more questions. I've not seen any audio related interfacing nor monitoring. Can you expand on this aspect?
Yes, so one thing we are looking at, because we do have customer requirements, for example, where they, for example, may need to take a live source, which is audio only. So that's one thing we're looking at, and that would be, for example, via a transport stream to do audio overs. And in terms of monitoring, what I would say is in the sort of Zixi infrastructure does enable some audio monitoring in that respect. One thing we're looking to add as well in terms of operators being able to audibly hear the audio is adding a preview on the user interface and be able to sort of select tracks. So they might want to, for example, hear a certain audio pair and just make sure that everything's okay. So yes, so that's the sort of thing we're looking at the moment.
All right, thank you. I think we've got time for one more question, and that will be how fast using coralPlay can you spin up a new channel?
Okay, yeah, that's a good question as well. So actually, to spin up a new channel, typically all we need to do is spin up the video pipelines. So if there is spare compute already available, we can do that sort of within a minute or two. If there isn't spare compute, sort of certainly in a cloud environment, then it'll take as long as it takes for that cloud environment to spin up another VM, because we use auto scaling. So that could be 2, 3, 4 minutes maybe. But yeah, typically that's how long it would take to spin up new channels.
Thank you very much. And I'd like to thank everybody for joining us today. We are up against the hour. We will be following up, sending out the recording to everybody that has attended, and following up with everybody that filled out the poll that wanted to talk to an expert from Coral Bay, from Zixi, or us together. So we will be doing that. And if you would like to have more information, please reach out to info@zixi.com, info@coralbay.tv, or visit our respective websites that are listed here. Thank you very much for everybody that participated today, our partners at Coral Bay, and we look forward to speaking with everybody again soon.